All right, this lesson video is for 5.7 Part A, where we'll do examples 1 through 10 on this page of notes, and then Part B for 5.7, we'll do the last 6 examples, which are over composition of functions. So today, we're just doing operations with functions, which means we are going to add, subtract, multiply, and divide with functions or equations. And these equations are all just given different names like f of x or g of x, h of x, it could be z of x, it could be anything, any letter. Okay, and this is just a way of classifying or giving names to our different equations. If we said all equations were like y equals, for example, here we have f of x equals 3x minus 7, and then g of x equals 13 minus 2x. What if I said y equals 3x minus 7 and y equals 13 minus 2x? And then I'm like saying, hey, add y with something else. I don't know. Like, you wouldn't know which equation we were talking about if we always just labeled everything as y equals. So by giving them these like different labels, so to speak, f of x, g of x, you know which equation they're talking about when they say to do operations like add, subtract with different equations, okay? So this first example says to do f of x plus g of x. So we're taking our f equation and we're adding the g equation to it. So our f of x, again, is 3x minus 7. So we'll put that down first. We're adding, okay, again, because that's what it says here, we're adding the g of x function, which is 13 minus 2x. Okay, so we wrote those out just like it said, f of x plus g of x, and now the only thing left to do is to combine like terms. So we'd start with our x's. 3x minus 2x is 1x. And then negative 7 plus 13 are like terms. They make positive 6. So what is f of x plus g of x? It is x plus 6. And another way to write this function, okay, f of x plus g of x would be to say f plus g of x. And again, this just means right here that x is a variable that we are using in the equation, okay? If it said f plus g of c, then c would be the variable in the equation, okay? But we just like to use x the most in algebra. So we have underneath here all of our different operations, okay? Sum literally means to add. So we just kind of did that one in our example. F plus g of x means we're taking our f of x equation and we're adding the g of x equation to it. Difference means to subtract. So f minus g of x means that we're going to take our f of x, it was given first, we're subtracting the whole g of x equation. And you would want to make sure you use parentheses around that second equation and distribute the negative in, because the whole second equation is getting subtracted from the first. Okay, product means to multiply. So this is read as f times g of x. So we're taking our f of x equation and we're multiplying it to our g of x equation. It's going to be like foiling, okay, a lot of times. That's all stuff we know how to do, pretty basic. And then we have our quotient rule, which quotient is to divide. Okay, it'll be set up like a fraction. It says f divided by g of x. So we have our f of x equation in the numerator. It's being divided by the g of x equation. Notice it has an asterisk next to it. Okay, we have some domain restrictions, because we can't let our denominator equal 0. And so we're going to have to find out which x values would make the denominator 0 and say that x can't equal that number. And that's pretty easy to find. So we say can't equal 0. Okay, so we'll figure that out when we get to numbers like 4 and 5 in the next few examples. All right, in these directions we are given 3 different equations. We're given f of x equals x squared minus 8x plus 4. We are given g of x is 4x minus 3, and h of x is x plus 2. And now, depending on what the variables are used in each example, okay, determines which equations we use in the problem. So, for example, number 1 says to do f plus g of x. So that means we're going to take our f of x equation and add the g of x equation to it. So f of x, again, it's up there underlined in red, is x squared minus 8x plus 4, and we're adding the g of x function, which was underlined in blue. So g of x is 4x minus 3. So very much like the example we just did, we're adding these two functions together. So starting, and remember all of our answers should be in standard form, which is our highest exponent down to our lowest or our constant. So x squared is our highest exponent. There's no other x squared, so it comes down. We have negative 8x and positive 4x to make negative 4x. And then positive 4 and negative 3 make a positive 1. So our final answer is x squared minus 4x plus 1. Okay, and then going back up here, we had a second part of instructions that said to indicate any restrictions to the domain. Again, domain is our x values. And for this problem, it's asking us, are there any like x's that are not allowed to be plugged in to our equations? And you only have restrictions really when you have a division problem. And that's, again, where we can't let the denominator equal 0. We do not have a denominator. This was not a division problem, so we do not have any domain restrictions. So we would say our domain is just all real numbers. Okay, and it will be all real numbers unless it is a division problem. Okay, so on number 2, let's look here. We have f minus h of x. Again, this means to take our f of x equation and we're subtracting the whole h of x equation. So let's show what that would look like. So again, f of x is x squared minus 8x plus 4. We're subtracting h of x, which is x plus 2, but we're subtracting the whole equation. So we had to put that in parentheses. And what that means now is that we'll distribute the negative inside. And if you don't do it this way, it won't be correct. So make sure when you do your homework, you're applying this principle. So this becomes negative x minus 2. Okay, and now we will combine our like terms. Okay, we start with our x squared. It's the only one, so we bring it down. It's negative 8x minus x, which is negative 9x. And then it's positive 4 minus 2, which makes a positive 2, so we put plus 2. And this is the final answer. It's as simplified as we could make it. And then our domain, which I'm just going to say with a D now. Again, this will be all real numbers because we don't have a denominator. It's not a quotient problem, so there's nothing to worry about restricting the domain. Okay, number 3 is read as h times g of x. So we're going to take our h of x equation and we're multiplying it to our g of x equation. So h of x was x plus 2. So let's bring that down. And we're multiplying it to g of x, which is 4x minus 3. And if it's multiplication, you need to put both equations or all equations in parentheses. They should be touching when you set it up because that's multiplication in math. And now this looks like x plus 2 times 4x minus 3. So it's a FOIL problem. So we start with x and we multiply it to 4x to get 4x squared. X times negative 3 is negative 3x. Then we come to our insides. We have 2 times 4x to make 8x. And 2 times, negative 3 makes negative 6. We're not done until we combine our like terms. They are the middle two terms. So this is 4x squared plus 5x minus 6. Again, do we have any domain restrictions? Is there anything that we cannot plug in for x? And the answer is no, it's not a division problem. So the domain is all real numbers. Okay, now we're on to number 4. This is a division problem, so going off what we just said, we will end up at having some domain restrictions in the end. So this is read as f of x divided by h of x. So we're going to put our f equation in the numerator, and that would be x squared minus 8x plus 4, and we are dividing it by h of x, and h of x is x plus 2. Okay, now you would check, okay, can we cancel anything out? Remember, like, this is a grouping, x plus 2. It could only get canceled with another factor that's x plus 2. So we would check, can we do 1, 2, 3 factor tree to this top question? Are there any two numbers that multiply to positive 4 and subtract to negative 8? Well, we got 4 times 1 is 4. 4 plus 1 makes 5. That won't work. And then 2 and 2 make 4 as well when they're added. So this is actually prime. It does not factor anymore. Okay, on Excel, number 6, okay, you are going to factor the numerator. So factor the top. And it's either a GCF or a slider factor tree. Okay, and then it will cancel, some part of that will cancel with the bottom. So it's a little bit different than our problem here on number 4. But because the numerator cannot factor. This is as simplified as we can make it. Okay, so that won't happen on the homework. There will be a part to cancel out. I wish I could show that here on these notes. So that is my answer. Now, we do have some domain restrictions. Remember, the denominator cannot equal 0. So we take our denominator, which is x plus 2, and we say it cannot equal 0. Okay, it's any x's that would make the denominator 0. And then we solve for x. That would just be minus 2 minus 2. So we would say here that x cannot equal negative 2, right? Because negative 2 plus 2, if we plugged it in to the denominator, does equal 0. And that is going to put you in math jail. We can't let that happen. So we would say the domain is x cannot equal 2, which means every x except negative 2. Sometimes it's easier to say what it can't equal than all the numbers that it can. Okay, so that's our domain here on that one. Okay, so number 5 is another division problem. We have h divided by g of x. So we're starting with our h of x in the numerator, and we're dividing it by g of x. So in the top, we'll put our h of x equation. So h of x, if you're looking at the top of your notes, okay, was x plus 2. So that is the numerator. It's being divided by g of x, which is 4x minus 3. So we're going to put that in the denominator. Again, x plus 2 is a grouping, okay? Think of these as a little couple. They can only go out with another x plus 2. That's the only thing that could cancel out that x plus 2. And then 4x minus 3, they are also a grouping or a couple. The only thing that could cancel that thing is a whole number 4x minus 3. We can't cancel out bits and pieces of it. Okay, they have to go out as a grouping. Okay, so I cannot, for example, take this x and this x out. That's illegal. That puts you in math jail. Okay, or the 2 and the 4. Again, binomials can only cancel out with binomials. Going out with like a little married couple with another married couple. Otherwise, we're home wrecking, I always say. So we get into that in more detail next semester. So there's nothing we can do to simplify this. So our solution is going to stay x plus 2 over 4x minus 3. So that's the answer. But what is our domain restriction? Okay, so for our domain, we're going to say that the denominator, 4x minus 3, cannot equal 0. So what was the x value that would make this 0? Well, let's solve for x. We add 3 to both sides. So we're saying 4x cannot equal 3. And then we divide by 4. So that means our domain is all x's except that x cannot equal 3/4. Plugging 3/4 into x would make the denominator equal 0. And again, that's bad. Number 6, we're doing f times g of x. So we have f of x, we're multiplying it to g of x. So our f of x equation was x squared minus 8x plus 4. We are multiplying that to g of x, which is 4x minus 3. Okay, again, multiplying means wrap them both up in parentheses and then distribute. Starting with the first term in the first set, we go x squared times 4x is 4x cubed. X squared times negative 3 is negative 3x squared. And then we move on to our next term, which would be negative 8x, and it gets multiplied to 4x for negative 32x squared. And then negative 8x gets multiplied to negative 3 to make positive 24x. And then we take our positive 4 and multiply it to 4x to make 16x. And then 4 times negative 3 makes negative 12. So we've multiplied everything that needs to be multiplied. Now we combine like terms, starting with our highest power term, 4x cubed. There's no other x cubed, so we bring it down. We have negative 3x squared with negative 32x squared to make negative 35x squared. Then 24x and 16x make positive 40x. And then minus 12 comes at the end. So this is our solution. Okay, notice it was not a division problem. There are no restrictions to what numbers we can put in for x. So we say the domain is all real numbers. So all of those examples we just had showed a little x inside the parentheses. Okay, now we have a number inside the parentheses. So when there's a little x inside the parentheses, your answers will have an x most likely in the answer. Okay, we keep it in terms of x. When we change it to a number, we're getting a number or constant as our answer. Okay, so on number 7, we've been given two different functions. We're saying f of x is 2x squared minus x minus 12, and g of x this time is x plus 7. Now we're going to compute these two functions for a certain value, and then we'll do something with those two answers that we get. So on number 7, it says f plus g of negative 2. So that would mean we're going to take f of negative 2, meaning we put negative 2 in for all the x's in f's function, and we're adding it to g of negative 2. Okay, so we're going to get two numbers from each of these things, and we're going to add them together. There's so many different ways you can do that. I'm going to show you the way that I do it because I feel like when you start using something other than addition for your function operations, it just makes it a little bit more simple. But again, more than one way to do this. I'm going to start by finding f of negative 2. So again, I'm using the function underlined in red, and I'm plugging negative 2 in for all my x's. So we have 2 times negative 2 squared, don't forget to square that one, minus, and it's x, so negative 2 minus 12. What's nice about these ones is that they are all calculator work. Okay, so I'm going to type all of this into my calculator, and it comes out to be negative 2. So we're going to save that and use it here in a minute. And then I'm going to figure out what g of negative 2 is. And remember, g of negative 2, we're doing x plus 7. So that would be negative 2 plus 7, which equals 5. So again, we're doing f of negative 2, which we just found out was negative 2. We're adding it to g of negative 2, which we just found out was 5. We're putting them together with addition. So negative 2 plus 5 is 3, and that's our solution. It's a number answer. Now, there's no x's left in this problem, so we don't have to worry about domain restrictions. Okay, so we only have domain restrictions if our answer is in terms of x, which it's not anymore. It's a number answer. All right, so let's continue that on. Number 8, f minus g of 8 means we're going to do f of 8 and subtract g of 8's answer. So let's start with finding f of 8. So again, using that same f function, but this time 8 goes in for the x's. So we're going to say 2 times 8 squared minus 8 minus 12. Again, all of this goes into your calculator, and it equals 108. Okay, so I could even put that down like right now. F of 8 is 108. What are we going to subtract? We're subtracting g of 8. So let's find out that answer. G of 8, okay, g is x plus 8, so we're going to do x plus 7, so 8 plus 7, and that equals 15. So f of 8 minus g of 8 is 108 minus 15, which just equals 93. And now it's done. Okay, now we have the last two examples for this video. Okay, the last 6 examples will be on part B's video. So number 9, we're taking f of negative 1's answer, and we're going to multiply that to g of negative 1's answer. So first, I'm going to find f of negative 1, and that would be 2 times negative 1 squared, again using this function right here, minus negative 1 minus 12. Type it all into your calculator. And that equals, what did that equal? That equaled negative 9. And then I'm going to do g of negative 1. So I'm plugging negative 1 into x for the g's function. So that's a little simple. It's just negative 1 plus 7, and that equals 6. So we are supposed to do f of negative 1, which is negative 9, and multiply it to g of negative 1, which is 6. So negative 9 times 6 is equal to negative 54. And that one's finished. Okay, number 10, we'll have an example with division. F divided by g of 5. So we have f of 5 in the numerator, and we'll divide that by the answer from g of 5. Okay, so let's find f of 5. F of 5 means plug 5 in for all the x's in f's equation. So we have 2 times 5 squared minus, and in parentheses we put 5, minus 12. And that's equal to 33. So 33 is our numerator. Now we're going to find g of 5. Okay, and that would be our x plus 7. So we have 5 plus 7 is 12. So 12 is our denominator. So we type into our calculator 33 divided by 12, and that comes out to be 11 over 4, all simplified. Okay, so again, today's lesson on Excel. Oh, and number 1 on Excel, I shouldn't have put that on today's lesson. It's false. Okay, our g of f, or f of g of x and g of f of x the same thing? No, they are not. And we'll talk about that tomorrow if you are actually watching this video. Next year, this homework assignment will probably be different. But do your assignment. Just remember, order does matter. Go in the order for which the equations are given and the directions. And we're just doing addition, subtraction, multiplication, and only one division problem on your homework. Good luck.